All right, this is a quadratic functions packet of the SOL review, and what you're going to do on this is use your calculator and plug in the value numbers from the solution set in for x. Do the left side, then the right side. So if we're going to try plus or minus 4, let's try plus 4. Okay, so we're going to plug in to the left side 4 squared, right? The left side was x squared, so now we're going to have 4 squared. That's 16. All right, now do the right side. So I'll label this here. This is left side. This is right side. You're doing this to see if they match. So now the right side was 16 minus 4x. Well, that's going to be 16 minus 4 times, again, we're using positive 4 in place of x. What do you get? You get 0. Do 16 and 0 match? They do not. So we can eliminate that as our answer choice. Let's try 2 plus or minus 2 radical 5 in place of x. Okay, so let's just try 2 plus 2 radical 5. Okay, so the left side, x squared is now going to be 2 plus 2 radical 5 squared. So you're going to plug that into the calculator just the way it looks, and you're going to get 41.8885. Now we're going to do the right side. So 16 minus 4x is going to be 16 minus 4 times 2 plus 2 radical 5. Plug that in and see what you get. You get negative 9.8885. Do the decimals match? No, they do not. So we can eliminate that answer choice. And we're going to keep trying. Now we're going to try 2 plus or minus 2i radical 3. Well, let's just try 2 plus 2i radical 3 in place of both x's and see if that works. So on the left side, x squared is going to be 2 plus 2i radical 3 squared. Type that in and see what decimal you get. So you get something like negative 8 plus 13.8564, and then there's an I at the end. So it goes on for a while and then it ends with an I. Now let's do the right side using the same value for x. I know it seems tedious, but it's worth it. Okay, you're just going to match decimals. 16 minus 4x is going to be 16 minus 4 times, make sure you use the same value for x, 2 plus 2i radical 3. Okay, plug that in and let's see what you get. This time you get 8 minus 13.856, and then a few more numbers and it ends in I. So these are very close, but are they the same? No, they're not. We need the exact same thing. So we can cross that off our list, and let's try the next answer choice. So on the left side, we're going to have negative 2 plus 2 radical 5 in place of x. Type that in. And you get 6.11145,618. Okay, now let's do the right side. So hang in there. We're going to get it. The right side is going to be 16 minus 4 times x. So that's going to be 16 minus 4 times negative 2 plus 2 radical 5. Notice how we're using the same exact value for x. And hit enter. And what do you get? You get 6.11145.618. Do your decimals match? They sure do. So, there's your answer. Good job. Okay, here it says the graph of g of x is shown. So it's U-shaped, or this time it's an upside down U, but that means this is a quadratic function. The question is, which appears to be a solution of g of x equals 0? So the key thing here is a solution is where your function crosses the x-axis. Okay? If it were a system of equations, if you had two different functions, then you would be looking for their point or points of intersection. But this is just one function, it's a quadratic function. So what you're looking for are x-intercepts. So look for x-intercepts. Alright, well, here's the horizontal axis is the x-axis, so I can see that it crosses the x-axis here at negative 3 and here at 1. Those are the solutions. So the answer choices are negative 3, negative 1, 0, and 3. So only one of them is showing up in the answer choices, and that is negative 3. So your answer would be A. If you have any questions, be sure to raise your hand. Keep up the good work. All right. Last but not least, before you guys do some practice problems, this question says, which of the following describes the root or roots of the equation 9x squared equals 6x minus 1? So first, what we're going to do here, remember roots are just another word for x-intercepts or solutions or zeros. Okay, those words are interchangeable. So what we're going to do here is first set the problem equal to 0. We're going to want to look at the graph of this one in order to select our answer. And remember, in order to use y equals, you're going to have to set the equation equal to 0. So since we're using y equals, we want to set the equation equal to 0. And that's done pretty easily. You have 9x squared equals 6x minus 1. Okay? We want to move everything over to the left side where the x squared is. So now we're going to have 9x squared minus 6x equals negative 1. All right, it's still not equal to 0, so add 1 to both sides. Remember, there are no like terms over here, so don't try to combine anything. We just have 9x squared minus 6x plus 1 equals 0. So now it's set equal to 0, and our next step is going to be to graph it on our calculator. So the next step is to graph this in y equals. So we're going to bring our calculator up, where we have 9x squared minus 6x plus 1. Go to y equals 9x squared minus 6x plus 1. We're going to graph it. And take a look at that. That's 1 real solution. Okay, as you can see, the vertex is right there on the x-axis. So solutions to quadratics are how many times, or the places where the parabola goes through the x-axis. Well, this comes down, hits it once, and then goes back up. So this, in this particular instance, we're going to have one real solution. And the answer that would match that best is exactly 1 root. Okay? Let's look at what they all look like. So copy this down. 1 real root would look like the problem that we had, where it hits the x-axis and bounces back up. Well, let's try that one more time. So I just want it to hit the x-axis and then bounce back up. That's 1 real root. Two distinct real roots. So 2 real. Here's your x-axis, here's your y-axis. 2 real would look something like this. Okay, notice it hits there and there. Okay? And then, last but not least, 2 imaginary, and there's no such thing as just 1 imaginary, so 2 imaginary would be a case where it doesn't hit the x-axis. So if it looks something like that, where it doesn't hit the x-axis, that means that you have 2 imaginary. All right? Well, our case looked somewhat like this one, okay? It hit the x-axis and then bounced back up, okay? So that's called, that's an example of where you have 1 real root, okay? So that's it.